Welcome back, physics fans. Glad to have you aboard here. Let's take a look at the Physics 11 projectile package. We're on page 7 where we're ramping it up and getting to angles and including angles here. Kind of like how question 11 hinted at the angle of landing that it was landing at. So we don't have the SOHCAHTOA worksheet. We didn't do it this year. So let's just have fun crossing that out. Okay, if we have a right angle triangle here with its legs to be 34 and 45, with those two pieces of information and that it's a right angle triangle, we can get the hypotenuse and the angle. Okay, and these are the angles and answers, and the hypotenuse, these are the answers. So let's just show you how to get that. This angle is what we're concerned about. So this will be the adjacent, ABJ, and this will be the opposite. Opposite because it's across, this one's adjacent. Okay, so to get the angle, we will use the tan because it's tan, TOA. Tan is opposite over adjacent. We have opposite and adjacent, so we're going to use the tan. This is a refresher of Math 10. Here we go. So the tan of that angle is equal to the opposite, 45, all over the adjacent, 34. So we'll put in 45 divided by 34, but we want the angle. We're not going to take the tan of it. We're going to take the inverse tan to get the angle. The inverse tan of 45. So how do you do that on a calculator? 45 divided by 34 is this number. And we want to take the inverse tan of that. So we could do it in one step this way. Second function, inverse tan. That's the inverse tan, see tan negative 1. Now I can type in that number or just do 45 divided by 34. 45 divided by 34. Close the bracket, boom. We get 52.93 degrees. Yay, we can do that now. That's a good refresher of the Math 10. Now, how do you get the hypotenuse? This is Math 8. This would be Pythagoras. C squared equals A squared plus B squared. So we want to take the square root of both sides, and that'll give us just C. And that's what we want, the hypotenuse, so the square root. So we have to take the square root of 34 squared plus 45 squared. And that'll give us that. So in one step, square root of 34 squared plus 45 squared. And that gives us 56.40. Yay, we can do that. Okay, so this angle here would be measured in physics and in math if this was an up and that, like in projectiles, horizontally and vertically. This would be above the horizontal or angle of elevation. But we write down above the horizontal, and we'll abbreviate that as ATH. And if it's an angle below, then this would be below the horizontal. And in math, that would be the angle of depression, I think. Here we go. So there's a quick review, 4 minutes into the video. Let's move down and try number 12. A ball is projected horizontally, still a horizontally launched one, interesting, with a velocity v, so we don't know it. Ooh, okay, that's probably what we're going to have to figure it out, right? V. From a point of 250 45 meters above the ground. Okay, this is 245 meters, and it's above the ground, so it's going to end up going down, all the way down to the ground. How long does it take to reach the ground? Boy, it doesn't look like we have very much information, but we have a lot more than what you assume or take a look at. Here we go. We're going to assume we're on Earth here, meters per second squared down, and it's launched horizontally, so there's a 0 there. Oh my goodness, there's 3 pieces of information here. And because the t is there, of 0, we can use the square root thing. The t is equal to the square root of 2d over a. And if you don't understand that, go back a few videos and you will see my shortcut explained many times. And 2 times 245 all over 9.8. So the square root of 2 times 245 divided by 9.8. 7.071 seconds. Yeah, that looks like an interesting number. I'm just going to square it just to see what it looks like. Square that answer. Yeah, it's the square root of 50. I thought so. Interesting. Okay, if it strikes the ground 84 meters from the starting point projection, what's the value of V? So we did get the time here, 7.071, 7.071, and if it lands at 84 meters away, then the velocity is going to be distance over time. So the speed is going to be distance over time, and the value of V is going to be 84 meters all over this root 50. Mathematicians, there we go, you'll appreciate that, root 50. Now you have to rationalize the denominator. Oops, maybe you're not a mathematician. 84 divided by that number up there. Okay, and that's 11.88 meters per second. And if it's asking for velocity, we should probably say horizontally. And what's the final vertical velocity? I haven't had to calculate that much. So if we're just only going to use the red ones, then without time, Vf squared equals Vi squared plus 280, 0 plus 2 times A, 9.8, and D, 245. So it's the square root of 2 times 9.8 times 245. Someone will say, why is it the square root? Well, it's Vf squared, is that? We want to find what Vf is, we have to take the square root. And that's going to be 69.30 meters per second, and that will be down. I have a sig fig issue there. Now combine horizontal and final velocity and final vertical velocity to get the final velocity. It just says final velocity. It doesn't say vertical, doesn't say horizontal. I want the final velocity. There it is. It's already hinting that I want something there. Let's see how we get that. Horizontally, it's still traveling at the constant 11.88 this way, and it's traveling downwards at 69.30. Okay, and now I'm just going to draw my resultant. It's change the color of that. Is that okay? I think so. Okay, not going to let me do that. Let's do it this way. Pen properties. Yeah, here we go. Let's make it red for resultant this time. Boom. Okay, now, before I calculate it, I need to stress for you guys, got to pay attention now. Everyone? Hey, Henry in the back, pay attention. I drew the horizontal first, and then from the top end of that horizontal, I went down for my vertical. It's best to always do it that way. Don't do the vertical and then the horizontal, because if you draw that, the angle that you get here is not the angle that's below the horizontal. You want the angle below the horizontal. So if you start with the horizontal first, then you'll get that. Okay, and then the second error that people do, well, before I erase it, let's just put them all together so you can see the errors and erase it, is they draw it this way and then they draw it this way. They got tail to tail, and then they don't know which, do you draw this? You're launching it backwards. So then you'd have to draw something like that, and then there's no triangle, then it's awkward. So my huge tip to you, and you must have watched this video to get this, you draw the horizontal one first, and then you draw the vertical one from the nose of the horizontal. Okay, there's my big tip. I'm glad you were watching. And so Pythagoras, the resultant vector v is going to equal the square root of 11.88 squared plus 69.30 squared. And Mr. Calculator has those numbers there, so I'll just use them. Square root of that number squared plus that number squared. So I'm keeping, looks like 9 or 10 sig figs. I get V, the magnitude is going to be 70.31 meters per second. And now I need this angle, and to put it there. So to get that angle, I have to do the inverse tan of the opposite over the adjacent. And if you're always doing the triangle this way, this is another hint. I'm glad you're paying attention to this video. If it's always that you've drawn the horizontal first and then the vertical, it'll always be the y over the x. It'll always be 69.30 all over 11.88. It'll always be that, because if you draw it this way, the opposite will always be the vertical. So it's the y over the x. So here's some rules there. It'll be the tan of the y over the x. Always. If you draw the triangle x first and then y. Nice, eh? So let's inverse tan and put these numbers in there. Let's go up there and get the 69 and divide it by that one that's just about to scroll off the screen. Close the bracket if you're worried. So then it'll be 80.27 degrees. And now this is below the horizontal, so I'm going to write down B, T, small t for the, and capital H for horizontal. And that is how you do the answer. Boom. Thanks for paying attention to your introduction to trig in physics here. And and Pythagoras, and that's how you get a actual two-dimensional vector out of it. And that's what makes this part of physics a little bit harder. It's still using Chapter 1 physics, it's still using Chapter 2 physics, but then we implement some Math 8 and we implement some Math 10. So yeah, it's just putting it all together. Finally a use for all that math that you've learned. And that is representing the velocity of impact. So it's traveling at 70.31 meters per second, and the angle is 80.27. So perhaps you launched an arrow, and it goes down, and when it hits the ground, boom. The angle that it hits the ground at is 80.27 degrees. So you measure the angle there, and boom, it's 80.27 degrees. And how fast was it traveling when it hit the ground? 70.31. Anyways, thank you very much. That's a wonderful 16 minutes that you've survived. Let's see what's coming up. Yeah, get a head start on that one. That will be pretty decent. Now, understand here, this is 2 seconds here, and this is 2 seconds. But then all of a sudden, what will its magnitude be after 3 seconds? This is a totally different question. So you can't take velocities that you've calculated up here, because it'll be after a different amount of time. Anyways, good luck. Try number 13 on page 8 ahead of me, and I'll get that up there. Thanks. Bye-bye.